So again, guys, we're looking at probability this week. The first thing we're going to talk about is mutually exclusive and overlapping events. The first thing I want to discuss are what are mutually exclusive events. Well, mutually exclusive events are events that cannot occur in the same trial. An example would be flipping a coin. If you were to flip a coin, you can't land on heads and tails at the same time. You either land on heads or on tails. They can't happen at the same time unless you had multiple coins. But if you're only flipping one coin, again, it can occur at the same time. So those would be considered mutually exclusive events. And then overlapping events we'll talk about in a little bit. So let's start by going over finding the probability of mutually exclusive events. Let's go over an example. So we have a dodecahedron. That has 12 sides that are numbered. From 1 to 12. So what is the probability of rolling, a little off screen, of rolling an even number or a 7? So the first thing we're going to do is we're going to write out our sample, and we're going to let A be even and let B be rolling a 7. So we're going to start off with our sample. Again, as you guys remember, a universal set is going to be our sample for this one. So again, we have 12 sides total. A is going to be even, so this is going to be A. And B is going to be rolling a number 7. Well, for B, we know it's only going to be 7, and 7 isn't even, so it's not even going to cross over into the A's realm. And A's are even numbers: 2, 4, 6, 8, 10, and 12. Everything else for our sample stays out. So 1, 3, 5, 9, and 11 are all outside of our two events. These are just other possibilities that we have. So looking at our sample, we know that there are 12 total. And let's look at the probability of event A. So the probability of having event A, well, we have 6 numbers in event A. It's just going to be 6 over 12, or 1/2. The probability for event B, as you guys remember, it's going to be the number for the set over the total number. So in this case, we only have one number in B out of 12. To find the probability of an even number or a 7, the key term right here is or, what you're going to do is you're going to find the number for A or B. We're going to do, there's how many total numbers in our circle? So we have 1, 2, 3, 4, 5, 6, 7. 7 total. Or 6 plus 1, which is 7, or 6 plus 1, which is 7. And to find the probability of A or B is 7 over our total number, or 12. So to find the probability of these mutually exclusive events, what you're going to do is to find the probability of A or B. Again, this is just for mutually exclusive events. You're going to do the probability of A plus the probability of B. So in this case, we had 6/12 plus 1/12, which gave us 7/12. For mutually exclusive events, to find the probability of this event or this event, you're going to add the two probabilities together. Okay, let's look at a different example. Let's look at overlapping events. So looking at overlapping events. An example of an overlapping event is if it can occur, or they have one or more outcomes in common. So overlapping events have one or more outcomes in common. One or more outcomes in common. And again, we're going to use that dodecahedron again with the same numbers. The only difference is we're going to find the probability of rolling a, let's say rolling an even number, or a number greater than 7. So again, for this one, we're going to set it up. We're going to start with our sample. Let A be even. And let B be greater than 7. So it's going to be greater than 7. So we're going to set up our sample again. With our Venn diagram, I guess you could say. And this A is going to be even, and B is going to be numbers greater than 7. So I'm going to start off with numbers greater than 7. Well, I know 8 is greater than 7, but 8 is also even, so I'm going to put it in between. 9 is greater than 7. 10 is also even, so it goes in between. 11 is greater than 7, but it is not even, so it stays over here. And 12 is greater than 7. And it is even, so it stays in our A set. So it's not mutually exclusive, it's still overlapping because these ones fit both A and B. And then, of course, we have 2, 4, and 6. Everything else stays outside of our events, but are still within our sample. We can still get those opportunities. So for these ones, let's start by finding the probability of these overlapping events. The probability of A. Well, we know the total for the whole set is still 12. We're going to count the number that is in set A. We have 1, 2, 3, 4, 5, 6. 6 out of 12. Remember, it's the number for the group over the total number. Now the probability of B. Again, we're going to count the number in B and set it over the total. We have 1, 2, 3, 4, 5 over 12. Now let's find the intersection of A and B. As you remember, intersection is what they have in common. So whatever numbers they have in common is going to be in this set. Well, the intersection of A, B, and A and B are 3, so they have 3 out of 12. We're not going to simplify these yet. We're going to wait till the end to start the simplification process. So looking at this one, we're going to start here to find the probability of these overlapping events. We're going to count how many total we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. Well, looking at it, the probability of A or B we know is 1, 2, 3, 4, 5, 6, 7, 8 out of 12, or 2/3. Well, how do we figure this out? Well, why do we find all the probabilities first? Let's talk about a specific rule that when we use overlapping events, we can follow. So this specific rule we're going to follow for A or B should give us this answer in the end. And let's check to see it. So this rule, we're going to take the probability of A plus the probability of B. And we're going to subtract what they have in common. So we're going to subtract the union of the two. And it should give us this answer. Let's test that. So the probability of A is 6 over 12. The probability of B is 5 over 12. And the A union B is 3 over 12. Well, 6 plus 5 is 11 minus 3. It's going to be 8 over 12, or 2/3. So this is the rule we're going to use for overlapping events. Now let's look at these as two-way tables. We're going to figure these out as two-way tables. So I do have some drawn up. I'm going to see if I can make sure that they're completely in the shot. If not, I apologize, guys. Let's see. So this is a boy, a girl, and that's the total, if it's hard to see, but I want to keep the numbers in there. Boy, girl, total. I'll write it off to the side. Boy, girl, total. Okay, so let's look at this one. We're going to find the probability of a senior or a girl. So for this one, we're going to start off with the probability of a senior. We're going to follow the same formula. We want the probability of senior plus the probability of a girl minus the probability of a senior girl. So let's look at the total number of students. There's N of the sample is 808 students. And we need to find the probability of a senior girl. So let's look at the probability of seniors total. Well, there's 202. So the probability of seniors is going to be 202 over 808. And again, I'm not going to simplify until the very end. Then we're going to look at the probability of having a girl or just having a girl. So probability of girl is total girls, 412 over our total number, which is 808. And then the probability of senior girl. I'm going to just put sen girl. The probability of a senior girl. Well, how many senior girls are there? There's 108 out of our total number of students, or 808. We're going to set these into our formula. Probability of senior girl, which is 202 over 808, plus 412 over 808, minus 108 over 808. If we add these numbers together and subtract 108, it should give us 506 over 808, which will simplify, because they are both even, to 253 over 404. That is our probability of having a senior or a girl, which is over half. It's over half. If you want to find out what percentage that is, we're going to take our calculator. Let's find the percentage as for this one. So we're going to do 253 divided by 404. Multiply that by 100. It's about 63%. 63%, or if you want to do another probability, you can do 0.63. Round it to the nearest hundredth. That is how you would find the probability for that one. And we have one more example before you guys get to work on your assignment for today. Looking at the airline daily flights, we're going to look at this one specific airline. We have domestic flights, international flights, if they came in late or on time. It's dependent on this one. So the first thing we're going to look at is the probability of a domestic or late. I forgot to put or late flight. A domestic flight or a late flight. So let's start with domestic. And let's go over the total number for the sample. So the total number for the sample is 180. So this airline has 180 flights in this given day. For the domestic flights, there are a total of 120 domestic flights. We're going to set that over the total number of flights. Remember, it's always what your number is for that group over the total number. So domestic flights, there's 120 of them out of 180. So we're going to do 120 over 180. Again, I am not going to simplify until later on. Then let's look at late flights. The probability of having a late flight. Well, let's look at late. So the way late's set up is straight down. Domestic was left to right. Late is up and down. So this is how many domestic flights are late. This is how many international flights are late. And this is the total number of late flights. So the total number of late flights is 18. We're going to set that over the total number of flights, which is 180. And we need the intersection of the two. So we need the probability of a domestic late flight. Remember, this is the intersection symbol. Now let's look at our table. This is the side that's late, and this is the side that's domestic. Where the two overlap is our late domestic flights, which is 12. Again, over our total number of flights, which is 180. We're going to have to follow our formula, as you remember, for the probability of domestic or late flights. You take the probability of domestic, I'm going to just make it a D, plus the probability of late flights, which is going to be L, minus the intersection of domestic and late. Well, we know our domestic flights are 120, so we're going to do 120 over 180, plus our late flights, which is 18 over 180. And then we're going to subtract the intersection, which is 12 over 180. If we add these numbers together, it gives us 126 over 180, which will simplify to 7 over 10, or 70%. A good way to check your percentage is, again, we have 7 divided by 10. Multiply that by 100. Gives you about 70%. The 100 changes it from a decimal to a percent. So it's about 70% for this one. And for your assignment today, I want you guys to look at your textbook page. Let's do textbook page 935 and 936, 1 through 20. You're going to do numbers 1 through 20.